Hello, today we're going to be talking about trigonometric functions on a unit circle. And we've already talked about the unit circle just a little bit. Essentially what the unit circle is it's a circle of radius 1 centered at the origin. And we've used that to figure out different angle measures. We've talked about it in both degrees and radians. And you can go in clockwise or counterclockwise rotation. Generally, positive is the counterclockwise rotation, and clockwise is the negative. So here are some values that are important. Okay, so t can be any number on a number line, and we let the point xy be the point on t when the number is wrapped into a unit circle. Then the trigonometric functions of t are as follows. So the sine of anything right here is going to be y. Cosine of any number is going to be x. And then the tangent is y over x. And then obviously the inverse, cosecant, would be the inverse of sine, secant would be the inverse of cosine, and cotangent would be the inverse. So essentially this is what we have to remember. And the way I remember it is like this. In the alphabet, C comes before S, just like X comes before Y. So I know that my cosine has to be my first point, and my sine has to be my second point when I'm looking at a point on the unit circle. All right, so we have functions that are on the unit circle. We call them circular functions. These are the trigonometric functions. And you have this in your notes already, but here is the unit circle. And you notice that these right here generally are the common 16 points that we need to know, and their corresponding degrees. So remember, 0 and 2 pi are the same. 0 and 360 degrees are the same. So if we ever wanted to figure out what the cosine of pi over 3 is, we'd look at the first point in my unit circle right here. The first point at pi over 3, which would be 1/2. If we ever wanted to know what the sine of 150 degrees is, sine is the second number. So it'd be the second number in this point right here. And you have this in your notes, like I said before, so you can use this to reference anytime you're looking for an answer. So let's look at example 7. It says find the exact values of each expression if undefined, right, undefined. So the first one I'm going to look at is the sine of pi over 3. Well, the sine of pi over 3, we just have to look at our unit circle. When you look back at the unit circle, pi over 3 has the point 1/2 and square root of 3 over 2. Now we're looking for the sine. And like I said before, the way that I always think of it is sine and cosine. Cosine starts with C, sine starts with S. Cosine, C comes first in the alphabet over S. So we look at the second point, and so my y is going to be my sine of pi over 3. So sine of pi over 3 is going to be equal to the square root of 3 over 2. Cosine of 135, well, if I look at 135, that would be this point, negative square root of 2 over 2, and the square root of 2 over 2. So here's my point. Now cosine, C comes first in the alphabet, so it's going to be my first part. So the cosine of 135 degrees is going to be equal to negative square root of 2 over 2. Letter C, tangent of 270 degrees. So now tangent is not one of the x or y values. So I have to look back. I know that 270 degrees is the point 0, negative 1. And I remember that tangent, remember, of anything is y over x. So my y value is negative 1. My x value is 0. Can you ever divide by 0? The answer is no. So this is undefined. Letter D, cosecant of 11 pi over 6. So I look at my point right here. 11 pi over 6 is the square root of 3 over 2, and negative 1/2. Now cosecant, remember, is the inverse of sine. So it's 1 over the sine of 11 pi over 6. Okay? Well, the sine, remember, is always the second number. So this is 1 over negative 1/2. And 1 over negative 1/2 reduces to negative 2. Here's some more examples. If you want to pause the video now and try these, we can talk about them tomorrow. So the next thing we're going to talk about is, what if you go around a circle more than once? Well, if you go around a circle more than once, we've kind of already talked about this. It kind of repeats itself over and over again. So you'll see right here, between like 90 degrees and 270 degrees, my sine values are between negative 1 and 0. And right here, between 0 and 180 degrees, my cosine values are between negative 1 and 1. But what happens if they get bigger? What happens if we continue to go around? Well, this thing kind of keeps showing up. Okay? What I can do is I can say that my cosine and sine values essentially repeat themselves every 2 pi radians, or every 360 degrees. This has got a special name. It's called a period. And periodic functions essentially are equivalent functions that work the same as the first time you go around the circle. And so what we can do is we can find that every time you go around 2 pi, or 360 degrees, it repeats itself. Now, tangent's a little different. Tangent doesn't repeat itself every 2 pi. It repeats itself every 1 pi. Every one time around the circle, it repeats itself. All right, so let's find this one right here. Find the exact values of each expression. So if I look at this one right here, cosine of 11 pi over 4. Now, 11 pi over 4 is not on the unit circle because 11 pi over 4 is more than one time around the circle. Remember, if our bottom is 4, a full time around the circle, 2 pi, would be 8 pi over 4. That's a full rotation. So what I have to do is take 8 pi over 4 away from 11 pi over 4. And so, essentially, it's the same as 11 pi over 4 minus 8 pi over 4, which when you reduce that down, is the cosine of 3 pi over 4. So I look at my unit circle at 3 pi over 4. I see my cosine value then would be negative square root of 2 over 2. Sine of negative 2 pi over 3. So again, this is going in the backwards rotation. So what we're going to do is a full rotation with a bottom being 3, denominator of 3, would be 6 pi over 3. So I'm just going to add that to negative 2 pi over 3. So essentially this is the same as sine of negative 2 pi over 3 plus 6 pi over 3. And so that reduces to the sine of 4 pi over 3, which is on our unit circle. I look at my unit circle, 4 pi over 3. My sine, my second value in that point, is going to be negative square root of 3 over 3. Tangent of 19 pi over 6. So what we said here is, earlier, is that my period for tangent isn't 2 pi, it's 1 pi. So what I would say is this is actually 6 pi over 6 would be one rotation. Now if I take that away, I'm still left with 13 pi over 6, which isn't on the unit circle. So we'll keep subtracting them until we finally get something that is. So tangent of 19 pi over 6, well, factors of 6 that could be taken out of 19, that would be, let's see, 3 times, so that would be 18 pi over 6. When I subtract those out, I get tangent of pi over 6. Now I look at my point. Pi over 6 is the point square root of 3 over 2 and 1/2. You have to remember that for tangent of any value, I do y over x. So in our case, it would be 1/2 over square root of 3 over 2, which would be the same as 1 over the square root of 3. Notice you can't have square root of 3 on the bottom, so I multiply the top and bottom by the square root of 3. And my answer then is the square root of 3 over 3. And I'm done.